Okay, let's see. This is a diagram of the the pipe and instrument, pipe and instrument, the diagram. And in this diagram, let's see that this is a diurite, the thermal diurite, and the water, the pure water, is came from this pipe into the diurite, and this is pressure, the low pressure steam is steam pipe. The steam pipe is give the steam to the diurite from pipe, these two pipe, and this pipe is the diurite. The diurite, the hot water is came from this pipe and through these two feed pump and to these main pipes, the main pipe to the boiler, and let's see, this is a diesel pump. When these two electric pump, if uh, it they are lose electricity, uh, and this diesel pump will start automatically to give the feed water to the boiler. And this is a fuel tank, So in this pipe and process, we see several instruments in our diagram and several control loop in our diagram. Let's see the first one. This one. This one we said this is a LT 160501. This one is a level transmitter. So this is the tag of the transmitter. We can find it in this. This is a BOILER feed control system I will list. This is instrument tag number. So let's see. This is a diurite level. The diurite level. The instrument tag is LT 160501. So is this one. This one is to detect the level of the diurite. And let's see, we detect it, and this instrument is a level. L is a level. I indicate C controller, and A means alarm. So it's with a function alarm controller, and it will give a high alarm and a lower alarm, and the controller's output will give to the valve of the pure water. So it means we detect the level of the diurite. If the level is lower, we should open this valve to give more and more feed water. If the level is higher, we should close this water. Uh, we should close this water and detect the uh, decrease this this flow of the pure water. So the controlled variable of this the controlled variable of this control loop is the level of the diurite, and this is the first control loop. So we can see this is transmitter, this is controller, and this is actor. The actor is the valve, and so this is a control loop. And LV means a level valve, and this ZT is a position transmitter. So the position of the valve, uh, the degree of the valve is from 0 to 100%. So the really degree, the actually degree of the valve is detected by the position transmitter, and it can indicate in our on our computer screen uh, to show the degree of the valve. And this is the first control loop. And the second control loop is at this position. We can see we detect the pressure of the diode and control the steam valve to control the steam flow. So this is the second control loop, and this is the same with this is a position detect this valve's position, relay position from 1 to 100% degree. This is the second control loop. Just like this, we can see the control loop, the PID control system. So the set point is the pressure set point. In our control system, is diode pressure. Diode pressure at this position we detect. So is a diode pressure set point, and this is a PID controller, and this is a steam control valve. So this is a steam control valve. This is a controller. This is a controller, pressure controller. And this is steam network. All the we see is a diode. So this is a diode and the pipe net, and this is a transmitter. Transmitter is pressure transmitter. Is this one is diode pressure transmitter, and back to the input, So just like this, I give you in WeChat. And let's say there are only two instruments in this position. This one is temperature detect, and this one is temperature indicate. So we should detect the diuretic's temperature at this position. These two, and these three instrument is local the pressure instrument near the pipe. We should detect the pipe, the water pipe, the pressure of the water pipe. And let's see the third control loop. The third control loop is at this position. We should detect the pressure of the outlet of the main pipe, outlet main pipe to the boiler. So we should detect this pressure. This is a pressure transmitter, and this one is a pressure indicate alarm. It lose a C. It's a controller. And we should control what? Control the pump speed. we should control the speed converter, through a converter. So this pump has a converter, and this 2B has another converter. We should through these two converter to control the pump speed, to control the water's flow, and to control the water's pressure. And this is the third control loop. And let's see, if we use the diesel pump, uh, in case of loss electricity, and it will use the diesel in the fuel tank. If the level were lower, we should open this valve, and if the level is higher, we should close this valve. So this valve only two position. This valve only have two positions, 0 and 100%. 0 and 100%. So this is a level transmitter to detect the level in this fuel tank, and this is a controller, to control this valve. But this valve only 2 degree, 0 and 100%. So it's only two state. One is open, the other is closed. And there is to detect the position of this valve, only 2 degree, open and close. We can find it in our IO list. These two singles. One is fuel tank level valve opens to the right place. This is closed, is shuts to the right place. There's a Boolean, a digital input. Okay, this is the mm, I think is mm, okay, one, two, three. This is three PID control, and this is only digital control in this valve, and there is temperature detect at this position. So